Hello everyone, welcome back to the series on Indian mathematics, Ganita Ratna Kosha. Now for the last few videos, we've been looking at multiplication techniques as to how we can multiply two numbers that are close to a base number like 10, 100, 1000, etc. Now we've looked at how to multiply numbers that are closer to the multiples of a base, for example 20s, 30s, 300s, etc. We've also looked at how we can square them easily. Now, to me, in mathematics, every technique, we realize the full benefit of the technique only when we understand how the technique works. What's the working behind the technique? So let's look at how and why this near base multiplication process, which we saw over the last few videos, is working. Let's assume the two numbers are a and b, are the two numbers we are multiplying. Let's assume x as the base. Let's call x the base. X is like 10, 100, etc. Now the differences will, let's denote them a as small a as the difference between the number a and the base x, and small b as the number b and the base x. Okay. So in the near base multiplication process, I wrote the two numbers like this, and then I wrote the difference a and b against them. X was my base, and then the right side was the product AB, left side was a plus b cross addition. Take one, or b plus a, either way. Okay. Now let's look at why this is working. Okay. So if I was multiplying AB algebraically, a into b is the same as, in this case, x plus a, so x plus small a into x plus small b. That's the same as x square plus a plus b into x plus ab. And if I take x as common, this is x plus small a plus b plus ab. I can further write it down now. X plus a is nothing but capital A. So this is x into a plus b plus ab. Now if you notice, AB was the right side part and capital A plus small b was the left side part. So if you can see the similarity between algebraically multiplying and this multiplication. Now as for different bases, the value will be different, because if I, let's say for example, if I take the base as 10, now this will be 10 into a plus b is the left side part, and the right side part is AB. And here, if you are comfortable with the place value system, so this AB is the units digit product of AB. That's why it can have only one digit, and we pass when base is 10. If you remember, we pass one of the digits, and this on the left side is the tens, the digits in the number in the tens place. Similarly, when x is 100, the left side part will be 100 into a plus b, and the right side part is, now this one is the units and tens digits. So that's why we could allow two digits here and we would pass the rest. And this left side part is the hundreds, the place in the digits in the 100 place. So that is how, if you understand the place value system, you can see why this multiplication method works. Now once we understand that's how this method is working, you will now be able to use it more confidently, and your speed and also accuracy will improve when you use this technique. Now let's look at where is this useful in our day-to-day problems. I find it very useful if you have to calculate net increase decrease of two consecutive increases and or decreases. For example, if the price of a commodity increases 4% and 8% in two consecutive years, and the question is what is the resultant percentage increase. So I am actually multiplying 1 plus 4 by 100 for the first year and into 1 plus 8 by 100 for the first year, that is 1.04 into 1.08, which is nothing but multiplying 104 and 108. Both are close to 100. Your right side is 4 8 32, and your left side is a cross addition 112. So this will be 11232. I have a decimal after four digits, so it's 1.1232. So the percentage increase is equal to 12.32%. So you subtract 1 from this, you will have 0.1232, that is nothing but 12.32%. So just by looking at the question, with some practice you will be able to say 4% and 8% consecutive increases will result in 12.32% increase. Similarly for decrease, if let's say the price of a commodity decreased 12% year on year for 2 years, so I am then looking at 1 minus 12 by 100 into 1 minus 12 by 100. So this is nothing but 0.88 into 0.88. Now I know how to do the square of 88. 88 square is, if I take 100 as the base, it's minus 12 whole square, and the left side is 88 minus 12. So that is 76 and 144. So this one will go here, 7744. So this is 0.7744. So the percentage decrease will be 1 minus 0.7744. Again I use all from 9 last from 10 rule, so that will be 0.9 minus 7 256, or this is equivalent to 22.56% decrease. So 12% consecutive decrease year on year for 2 years will result in 22.56% decrease. Now this is how we can use the near base multiplication a lot of times in the day-to-day problems, mathematical problems or arithmetic problems we come across. Please do stay tuned into these videos. From the next video onwards, we will look at other multiplication techniques, and please do write to me for any clarifications or suggestions.